Okay, for the generator example, a shunt dynamo and a battery of accumulators are in parallel. The dynamo has an induced EMF of 100 volts and the battery has an open circuit EMF of 110 volts. The dynamo resistance is 0.40 and the battery resistance is 0.50. What is the common terminal power delivered and what is the current delivered by each if the current is 40 ampere? So the current of 40 ampere, the load current. So let's write the given shunt dynamo of, we have a generator of induced EMF, so EG of 100 volts, and a battery EMF open circuit, so let's write EB for the battery, 110 volts, and the resistance of the dynamo, the total resistance of a dynamo or the generator, so RG is 0.40 ohms, and the battery RB is 0.50. Now, at condition of the IL or the load circuit or load current is 40 amperes, what is the, let's write the required, what is the current, let's write IG and IG and IB. So first, let's draw the circuit. So a parallel, it is a shunt dynamo, but it is solution. In the problem, the total resistance of the generator or the dynamo is already given. Therefore, we write this one. This is the EG, and this is the total of the generator or the dynamo, and this is the output at common terminal. And here is the parallel battery with a resistance of 0.55, EMF of 110, and if the current or the load current is 40, what is EB and DEG? What is the current from the generator, which is IG, and from the battery, which is IB? Okay, from that circuit, we have to write this as RB, and this is as EB. EG is equal to 100, EG is equal to 0.4. And then let's have a nodal analysis at this point for V. Let's write V here. Then we have, or there are many approach of this to this problem. We can use nodal analysis, which is IL. Step 1, IL is equal to IG plus IB, where the common voltage V. So we have IL is given 40 amps. 40 amps is equal to IG. We have 100 minus V over 0.4 plus the IB. We have 110 minus V over 0.5. So let's use this equation. So we have V of 95.55. So V of 95.55 voltage. This is the terminal voltage or the common voltage. Then let's find IG. So IG is equal to, here this is IG and this is IB. So we have 100 minus 95.55 over 0.4. We have 100 minus 95.55 divided by 0.4 be 11.12 amperes. So IG. Step 2. So we have IG. To get the IB, we can simply subtract from this equation, which is IL minus IG. 40 minus 11.12, it is 28.40 minus 11.12, 28.88 amperes for the IB. Okay, to get the terminal power delivered at the terminal. So we have third darker. So the power at the terminal, or the power output, we have the common voltage or the VT terminal times the IL or the current at the terminal. We have 95.55 volts times 40. We have 95.55 times 40 is equal to 3,822. So 3,822 watts. Okay, we have the answer, the IG, the IB, and the P out. Thank you.